Measurement of segments, Level 2. In this video, we will start taking a look at simple examples that require us to find the length of segments and use the concept of congruent segments. Before we start, a word of caution. From this point on, I will be assuming that you are very well versed with the basic concepts and skills learned in a typical Algebra 1 or beginning algebra course. You should be comfortable solving equations with a single variable, solving systems of equations with two variables, working with fractions and decimals, and translating word problems into equations. If you're a bit rusty, I recommend you brush up on these skills before proceeding. With that said, let's go ahead and take a look at the first example. Name three segments congruent to segment PQ. In this problem, we are provided with a number line that contains various points. Each point has a particular coordinate. We are asked to name three segments that are congruent to segment PQ. Recall that congruent segments have the same length. We first need to figure out the measurement of segment PQ before we determine which other segments are congruent to this segment. The coordinate of point P and point Q is -2 and -1 respectively. Taking the absolute difference of both coordinates and simplifying, we obtain 1 for the length of segment PQ. Now that we know the length of segment PQ, let's go ahead and find three other line segments that have the same length. One line segment that has a length equal to 1 would be line segment QR. Another one would be line segment RS, and the last one would be line segment ST. So these three line segments would be congruent to segment PQ. Alright, let's try the next example. The given numbers are the coordinates of 2 points on a number line. State the distance between the points, -2 and +6. In this problem, we are given the coordinates of 2 points, and we are asked to determine the distance between the points. Notice that in this problem, we are not provided with a diagram or figure. We're going to have to draw it ourselves. So let's go ahead and draw a number line and use point A to represent the point located at the coordinate -2, and use point B to represent the coordinate located at +6. Now that we have this visual as a guide, we can go ahead and find the length between point A and point B. Similar to the previous problem, we go ahead and find the absolute difference between the points' coordinates. Doing that and simplifying, we obtain 8 as our answer. Notice that in some geometry problems, you will be responsible for drawing the diagram of the problem. At times, you can get away with not drawing the diagram. I personally do not recommend it. Okay, let's try the next problem. Name each of the following. The point on ray DA whose distance from point D is 2. Here we are provided with a number line that includes various points. We are asked to name the point on ray DA whose distance from point D is 2. Let's start by drawing ray DA. Next, we need to determine the point that is 2 units away from point D. Starting from point D and moving in the same direction as ray DA, we see that point B is 2 units away from point D. So point B is our final answer. Let's try the next problem. The point on ray DG whose distance from D is 2. Similar to the previous problem, we want to determine the point whose distance is 2 units away from point D and is located on ray DG. So we start from point D and move in the direction of ray DG. We see that point F is 2 units away from point D. So point F is our final answer. Let's take a look at the next example. 2 points whose distance from point E is 2. Now we need to determine which 2 points are 2 units away from point E. Since we can only move either left or right in a number line, all we need to do is to find the points that are 2 units away from both directions. Starting at point E and moving 2 units to the left, we see that point C is located 2 units away from point E. In the same manner, starting from point E and moving 2 units to the right, we see that point G is located 2 units away from point E. So point C and point G is our final answer. Let's move along to the next example. A segment congruent to segment AF. Now we need to determine which segment is congruent to segment AF. First, let's determine the length of segment AF. So we take the coordinates of point A and point F and use them to compute the length. Taking the absolute value of the difference of these coordinates and simplifying, we obtain 5. Now we need to find a line segment that also has a length of 5. Notice that the only way to get another line segment with a length of 5 is by moving segment AF 1 unit to the right. This new line segment has point B and point G as endpoints. So a line segment that is congruent to segment AF is segment BG. So this is our final answer. Alright, let's try the next example. In the figure shown below, find the following. The length of segment PQ. In this problem, we are provided with a partially labeled number line, and we are asked to find the length of segment PQ. We can easily determine the length by finding the distance between point P and point Q. Recall that we can determine this in a couple of ways. We can use the number line to count the distance from one endpoint to the other endpoint. We can also find the absolute difference between each of the points' coordinates. Regardless of how we decide to find the length, the measurement of segment PQ is equal to 5. Let's go over the final example. If point R's coordinate is 7, why is line segment PQ not congruent to line segment QR? The next problem is asking us to explain why line segment PQ is not congruent to line segment QR when the coordinate of point R is equal to 7. Recall that 2 line segments are considered to be congruent if they have the same length or measurement. We know from the previous problem that the length of line segment PQ is equal to 5. Let's go ahead and find the length of line segment QR by using the coordinates of the endpoints. Finding the length and simplifying, we obtain 4 for the length of segment QR. Since the length of both line segments are not the same, we can conclude that segment PQ is not congruent to segment QR. We can denote this symbolically by using the congruent symbol with the / going across it. This is similar to the does not equal symbol introduced in your beginning algebra course. Alright, in our next video, we will go over slightly more challenging examples.